Hi everyone, and welcome back. This is class 3 of the series of tutorial about impact dust. During this class, we will talk about volume sourcing. We will study the basic setup that we have thanks to the shelf tool. We will study how it works. We will see its limits for what we need, and we will start building our own setup. Just one thing, I mentioned earlier in the previous class that I will talk about stepping. Okay, this thing that we have here in the emission. This will be for the next class. Basically, I realized this would be too long for one video, so I decided to separate the topics and talk about the volume stepping in the next class. Okay, so the shelf tool is creating for us these nodes. Okay, just behind our node, the geometry node that we had here. All right, and so the workflow that we have now, thanks to the shelf tool, and which is the default setup that we have, is that we convert this geometry into points, okay? Then we work on the point, we add some noise, we do something in there, and after that, finally, we convert that into a volume. So I think this process, this workflow came with 17.0, or maybe version 16.5 of Houdini, but I think it's 17.0. You still feed a volume inside the simulation, but the way you prepare this volume is quite different. You could do a VDB from Polygon, okay, and create a volume here for VDB as a density, and then you could feed this density inside the pyro sourcing. Now, the thing with this is that if you want to add some noise into the volume, it takes some time to process, okay? It's much longer to process noise in a volume than it takes to process noise onto a point. So I think that's why they switched to this workflow. And now you create the points, you put any noise that you want on it, on all the attributes you want, and in the end, really at the end, you convert that into a volume. And this process, which is by only the longer to process, is only done at the end, so you have all the time to actually visualize your parameter here before converting them in the final process. Okay, so let's look at how we create the points with the default setup. Here, this is so the what called create density, but it's really creating density and temperature by default. Okay, and you could remove that. And actually, I'm going to use only the density. You can initialize it to emit also fuel. You can also add the color to it. Really, I am going to use the smoke only and the density myself. You have 3 modes to actually define the points on the object. So you have the surface scatter, which is the default one. You have the keep input. So it's basically here going to keep the input that we have here. So if we visualize the points here, and then we go here, you see that we have exactly the same points. And whatever the separation that you put here, it's not going to change anything, okay? And then finally, you have the volume scatter. So it's scattering points inside the shapes. So if I reduce the separation, then you can see, oops, selecting this, okay, then you can see that it's creating the points inside. And if I reduce even more, then you can see that we define even better the volume. Maybe this scatter is not really the word, because it's all organized nicely, but that's the way it works. It creates points inside the volume. I am going to use the surface scatter only. Why is that? It's because I think that in our case, the fragments are not emitting dust from inside their volume. They are really emitting dust from outside, from the surface of the shape. Let's imagine some fragment there. The dust would be peeled off by the wind or by the velocity, peeled off the surface of the fragments and not from inside. So I'm really going to use the points like a texture emission, okay? So that's why I'm using the surface scatter. And then you can add more points by just reducing the particle separation. At this point, it's really like if you were doing a scatter operation here, okay? And increasing the number of points. This is really the same so far. on it. Except that this spiral source here gives you the opportunity to the possibility to add some attributes, and for instance the velocity. So if I display now the velocity, I see I can have the velocity that is transferred onto this geometry. All right. Then you can add some noise. So I'm going to show you how to visualize this. So if you press the X key and click on it, then you have a visualizer node. And then inside the visualizer here, I'm going to display its density. And I'm going to hide this. And come on. Y. B. What's happening there? Density, create the density. Okay, so I might have some issue with my scene view. Okay, create a new scene view. Scene view. Okay, I do have a problem. What's happening? It's cooking. Why? Yes, because it was the scene view was created in the in this view, and I had this guy displayed, so it was trying to simulate, but I don't want that. There we go. So here I have my visualization. Okay, so it's there moving. And I visualize the density just to double check. If I put 0 here, then density, sorry, this is velocity. If I put 0 here, yes, okay. And then if I increase this, it's actually working well. So I'm visualizing the density here. And then if I go here to the add noise, then I can see that I have some noise added to the density. Here are the attributes that the attribute noise is going to noise. So I'm getting rid of the temperature. Okay. The noise is based on this location attribute, the P, the position. Fine, we can tweak that later if we need. And then you can change the actual frequency or the size of the elements, and then you can see that the patterns is getting smaller. So you make some noise here on the density, and then you rasterize this. And when you rasterize it, it might take a bit of time because there I have quite high voxel size. Actually, sorry, a small voxel size. I'm going to increase that. And now we have this. We don't have much density. If you can increase it if you want, okay, then you have this. If you want to keep this density but still want to visualize it even better, you can use a volume visualization there. Go there and say increase the density scale. All right, you can do that. So it's going to display the density as if it were 10 times bigger, but still inside the volume you would have this value of 1. All right. Okay, so this is just a trick. You might need that later also for the dust simulation. When we have some simulation and you want to visualize it a bit better, it's good to actually change the visualization in the viewport, but not in your cache. Now let's have a closer look at this pyro source node here that is creating the point for us. This one, if you press play, you see that it's actually not really real time, you see. And this is because of the number of points. Obviously, if we increase the particle separation, then it goes a bit faster. And if we reduce it even further, then it goes even faster. But we need points. We need a lot of points. The 0.5 here gives us something interesting, but it's not precise enough. It's not really covering everything from the shape. And because I want to use it like a texture, I want to fine control here, and I'm going to need a lot more points. So to be able to work in a faster way with this node, there is the second branch here, the second input, sorry, where you can feed rest geometry. Okay, so I'm going to use a time shift here. I'm going to plug here. I'm going to break this connection so that this time shift stays only on frame 1. And what's happening is that now the create density here is going to create, the pyro source is going to create the points on this time shift and then move it according to this geometry, according to this movement that we have here. And now if I press play, now I'm real time, you see, on 24 frames per second. And actually, if I increase the number of points to let's say 0.1. It's calculating now, you see, but it calculates it only once, and then it's real time. All right, so that's really cool. Okay, so we want to work with this, so that's one good thing. And now let's see if we have all the things we need. So in this create density, then I have the velocity. Then let's look at the velocity here. Okay, so I'm displaying the velocity. So far it's 0. And I'm playing, and I still have 0 for the velocity. So let's look here and visualize only the velocity. Okay, I have 0. And really all the time, the entire timeline, I have something which is 0. Okay, so let's get back a little bit. I'm going to reduce the number of points, so get back to 0.5, and I'm going to kill this. Okay, and now I have the velocity here. All right, so what's happening is that really when we are creating the points on this frame one, okay, it's also getting the information, the velocity information, the attribute from this frame. Okay, so if I put frame 60 on this one, then I have this velocity. But you see, the velocity is not moving with time. It's not changing. It's really snapping this velocity. It's taking a snapshot, sorry, of this velocity at frame 60, and then it's converting, it's transferring this velocity to the animation. And this is not what we want. We really want the velocity to be varying with the animation. Okay, so okay, we could use a trail here just behind it. Okay, and then you calculate the velocity, and it would be well, sorry, I'm so used to have it. Yeah, and now the velocity is calculated, and then you have a different. The velocity is changing with time, and then you have something which is working fine. But it's also doing the same for, let's say, if I do that, and if I do a custom, and I put the normal there. All right, so if I display the normals, then you can see that the normals, and well, the normal is vector attributes. There we go. And then you can see that the normals are completely static, and it depends also on the frame that you are using here. You see? All right, so that's not working. You can, I mean, I could do a normal just behind as well and compute the normals. Actually, no, it wouldn't work because we have points only, and then it would be completely lost to be able to calculate the normals, because you can only calculate normals on this, on a geometry like this with polygons. All right, so at this point, I need another way of actually making my my points and transferring the information I want. And basically, the information I want are the velocity and the normals, among others, but these ones are really important to me. All right, so let's see how we can do that. The way I create those points on such a moving geometry and in such a case, and this is just my way, maybe there are other ways, but this is how I'm doing it. I know I'm going to need a scatter, okay, and I'm going to scatter this onto my geometry. So let's do that. Kill this. Okay, whatever. So I know I'm going to need a scatter, and I know I need to do that on a time shift because I need to do that on frame one. Okay, so I'm scattering here. I'm hiding this. I'm scattering the points on my frame one. Okay, here. I know I'm going to do that. I'm going to reuse the same principle here, that I need to scatter on the first frame and then move the points with the animation. And so I prefer to work with the density scale so that I can control that a bit better. I prefer to work this way, but you could use this. It's fine. And then what I know I need to do is I need to interpolate the points and the attribute from the static geometry, well, this part, which is static, which is not animated, onto the animated one, which is here. Okay, so we see this, and we need to interpolate this onto this geometry. So how to do that? Well, there's an attribute interpolate sub, which can help us doing this, which is actually doing what we want. You can go into the documentation and you find it here, okay? And what it's doing exactly, it's going to take a destination geometry. This is where we are going to interpolate the attributes to, okay? And this source attributes from the original geometry. And okay, so the way it works is that it takes some the address of the point, this one. I think the address is one fine way of explaining how it works. Like this scatter here is giving birth to points onto this geometry at frame 1. Actually, let's display this one. Okay, so we have the points that are created. Let's say, for instance, here, this point is created onto this primitive, okay, at frame 1. So his address would be this primitive number and some UVs onto this primitive. And so for that, you need on the scatter to output the primitive number attribute, okay, and the UV inside this primitive. So it's like, okay, which city are you? And in this city, what is the address in this city? Okay, so the city is a primitive, and the UV is the address inside this city. Oops, there we go. And now, so we know where this point was born. Okay, so this guy here, it was born on this primitive. If I display primitive number and bring that one, okay, it's too much of a mess. But basically, yeah, okay, there we go. Okay, fine. It's this primitive, okay, and in this primitive it has some UVs, and so it knows that it was born there, and then when it moves, and when this primitive is moving with time, okay, the point here is going to tell the attribute interpolate. Well, I was born there at this primitive, and at this address on the primitive, at this UV on the primitive. And so the attribute interpolate is using this by default, okay? This is the primitive number and the UVW on the primitive. It's using this to interpolate the point and put it back onto its respective geometry, respective primitive, okay? All right, so it's moving like this. And here you decide which point attribute you are going to interpolate from the moving geometry onto the static, and there is P in there. P is also interpolated, and that's why the point is moving to the correct position. But we have P, but we also have CD, we have V, and we have the normal as well. Okay, so if I display the normal, there we go. And the normal is actually moving with the object. It's not static anymore. You can see it here, you can see it here. And I have the same for the velocity. So if I hide all attributes and display the velocity, and then you have it here as well, moving, you can display the velocity, and you see that it's actually 0 now at the beginning, and then when it starts falling, it's actually following the movement, and we have now the correct velocities. Okay, so this is the way I do it. This is the way I interpolate the attributes onto the point, sorry. Well, now we have this interpolation there. Well, it's really easy to fit it with the rest of the setup, the rest of the basic setup. So can come here. I actually don't need this anymore. All right, and you can add the noise, any noise you want to it. All right, so if we visualize it, then we should have the density here. You can change the noise again, increase this. Okay, or maybe I'm gonna put some more points. Density scale, put it to 300. Now we have these points, and then you can change the actual density there by just increasing the size. Obviously, I should maybe initialize it before. So attribute create density, and I'm going to create that density here and give it a value of 1. Okay, so by default you have this, and then you add the noise onto it. Okay, so we have default value of 1 instead of having a default value of 0 and then adding the noise to it. It's just up to you. And then you rasterize it. Okay, same as before. I'm going to reduce the particle scale to 1 so it gets closer to the actual geometry. Okay, this is what we want. Okay, I'm going to get rid of the noise for now. Okay, so we need to have something as close as possible to the geometry, so you can reduce the particle scale. And now we see we get a bit closer and closer. Maybe this is too small. Bring this back. Okay, so we have this, but then maybe we need more points. And then this is really going to be a balance between the two. Let's put more points there, and then rasterize this with a value of 0.5. Let's hide this. Let's look at it with an increased density. Yeah, that's a bit better. So we have something which is actually closer to the shape, okay, with the volume rasterized. And now you can bring back your noise here. So we have some of the fragments that are not emitting and some of the fragments that are emitting. Okay, well, good. Let's check that it's actually still emitting from the dust. So I go back here in the camera and I'm displaying this guy and I press play. And now, yes, we still have the emission working. We see that some of them only are emitting, some of them are not. Okay, so we have much less emission than before. And it's actually moving through a noise, so we have some holes into the emission. Okay, far from what we want, but at least we know what we've done is working. Okay, before finishing this class, I want to do one last thing about the volume sourcing. Is the same as we did for the wall simulation here. We need to cache our emitter. Why? Well, it's because it's taking time to compute this this volume here, and this time which is consumed here is actually slowing down the simulation here. And I want to be able to work well, not really real time because because with high resolution here, I won't be able to work real time. But once this is ready, I want to be able to focus only on my simulation and not have this calculating at the same time I have the simulation calculating. So what I want to do here is to do a cache. I'm going, lazy me, to copy paste this, okay, into this one there. So I'm going to get to move this apart because really I want to bake this onto disk, okay? And then I'm going to read it back in here. And this is the one that I'm going to feed inside my simulation. And remember here, the volume is really looking for out density. One thing though, I don't like to call it out density. I want to call it out volume here. Because really it's not only density, but it's also about the velocities that we are going to put here. And we have the CD here, which I'm going to remove because we don't want that. Okay, so on the rasterize here, I'm only going to keep density and the velocity. And this is what we have here. Okay, cool. So now back to the caching part. Here, I want to cache, yes, I want to cache my emitter from frame 31. Good. To frame 150. Well, not right now. So I'm going to put frame 100 so far. And then it's going to cache that into the geo animated. Yes, it is animated. So it's going into this folder. Okay. So then it's called wall emitter geometry. Well, this is not a geometry. This is a volume. So I'm going to call that volume, wall emitter volume. Okay. And we have then the frame padding, which is correct. And now let's check that this is loading the correct one. Yes, frame emitter volume. And now let's do a bit of refinement here. Scatter, let's look at it. I'm going to increase that. Maybe a bit more. Okay, now I have a lot of points. It's a bit closer to what I want. And then I go to the rasterize. Check what we have. Going to get rid of the noise for now. And I want to have maybe something which is a bit more like this. Maybe I need more points then. Let's do that. Okay, maybe a bit better. It's finer, okay. All right, it's better, but I think I'm going to go back to 2000 here. Just for the just for now, not the voxel size. It was there, just particle 2, and then I can reduce the voxel size maybe a little to have maybe something a little closer to the yeah, that helps. Okay, so it's a bit more balanced between the parameters, and I'm going to go for that with that for now. Because I want to cache this quite quickly and see if it's working. Okay, so Save to disk. All right, so it's calculating 70%. Okay, now it's done. And I'm going to go here into the geo animated, and I should have my wall emitter volume. And in there, I have my emission there. Okay, cool. So I have 102 megabytes. So that's good, but still we can do a bit better. Like I told you, we need to optimize the data written onto the disk. So two things here. The rasterize is creating VDBs. That's good. In case, I mean, the rasterize is doing VDB, but if you have volumes, if you adopt a different way of doing it, if you have volumes, use VDB, convert it to VDB. So you use a convert VDB here and convert the volume to VDB. Because the VDBs are much more optimized than the native volumes inside Houdini. And then there's still something you can do. Lay down a primitive node. Okay, branch it here. This primitive node, you have something on the volume tab and on the VDB tab. Check this on and check this on. So you activate this option and then you say, okay, write 16-bit floats. What is it doing? The VDBs usually are 32 bits, okay? And it's writing the information with 32 bits on disk. We don't need that much information. Seriously, at least for the emitters, and even for the simulation, we will see that later, we don't need that much information written to disk, okay? So what usually you can do is go with this primitive, write 16-bit floats, and now look at it. Here we have 102 megabytes for the wall emitter volume, okay? I'm going to call that back, and I'm going to cache that again to disk. Well, still working. It's going quite fast. Now this is, there you go. We have half the size of it, okay? Again, this is that much less information written to disk, and that's much less information that you are going to pull over the network, okay? And that's much less information that you will have inside the memory. So take this habit. I'm going to delete this guy. Take this habit of writing to 16-bit. I'm going to do that here because obviously I'm going to reuse this setup here and copy paste it to the other emitters. All right, cool. Well, now just one last thing. Obviously, I need to reload the geometry. There we don't have anything, so I need to use, because I don't want to have this problem, I need to use the time warp again. Okay, I go here and use this time warp. And now the time warp is working fine. Okay, so it's going to 150. We can leave it this way because later I'm afraid of I forget to change it to 150 when it's on, and it's working fine. Let's double check. Always double check what you're doing, but it's working fine up until frame 100. Let's see. Okay, what's happening? There we go, and it's following my geometry, so that's fine. Okay, loading, fine. If I go here, go back into the camera mode. It's cooking. Okay, it was solving something. I go back into the camera mode, and now I press play, and I have my emission working correctly. Now all the fragments are emitting constantly. I still have the stepping, more on this later, and it's working fine with my cache. Okay, I mean it's using here the cache, this one, the one on the volume. All right, cool. Well, that concludes the class 3. I hope it's working on your side, and I'll see you in a moment for class 4. Goodbye.